Okay, so for those yang tak tahu, after week 9, your class will be, your physics lecturer will be Dr. Suzy. Aduh, janganlah buat sedih macam ni. Saya bila orang saya sedih, saya gelak tau. Waktu ni bila dah lama sikit baru saya sedih juga. Sekarang week 6, so we have another 3 weeks, right? So this is week 6, week 7, Monday I will do revision, and then your penilaian 1 is on Wednesday. Okay, so after week 9, which is week 10 lah, week 10 Dr. Suzy akan ganti, but I will be recording all my classes with my other class, so you guys can still watch them and you can ask me questions too, boleh, okay? So not totally gone. So that is the info. I think yang baru masuk tak tahu pasal ni, because I think I mentioned it early on in the class that I will be teaching half of the semester only. Okay. Dr. Suzy is good. She's really good in math, which I'm not. Dia pandai math, saya pandai merepek. Satu perbezaan kita orang. Okay, jap, let me pin myself. I already pin myself. Okay, making this single. Okay, so let's continue. Okay, let's do a little recap first. Macam biasa, duplicate slide, new slide. Okay, so revision pula. Web assign, korang punya assignment is due on Wednesday, due on Tuesday, tomorrow. I think I have several questions about that. Can we like take around 10 minutes before class ends to like discuss apa soalan yang macam pelik-pelik sikit ke, unique clarification? We'll do that at the end of the class, okay? So sekarang kita kena fokus dulu chapter 3 because I need to finish this syllabus. If not, I'm going to be in trouble. Okay, so let's do our recap. So for chapter 3, we talked about the different forces. I'm recording. Okay, we talked about the different forces that can happen or that can act on a body. But before that, we already talked about Newton's first law, second law, and third law. First law was law of inertia. Second was F equals to ma if mass is constant. The third one is equal and opposite forces, meaning to say the force cannot exist on its own. It has to exist in pairs, but the pair should be equal and opposite in magnitude. And we saw the third law happening in equilibrium, objects in equilibrium. For example, when this box is on a table, okay, this is a table, walaupun buruk. This is a table, so the box applies a force because it's exerting gravitational force on the table. So the table does not like this. I want to like push back on you. I won't let anyone bully me. So the table is also exerting the same amount of force. This is called F table, let's say, and this guy is called F, box, right? So F table and F box is equal, but they are opposite in direction. So conventionally, we would say that forces that goes down is a negative and the forces that goes up is a positive. So Ft is equal to Fb. If F is equal to 10 Newton, then this would be 10 Newton going up, and this is minus 10 Newton going down. Fb is going down. So they have equal magnitudes but opposite direction. And we talked about the different forces that can occur or that can happen on an object. For example, kita dah cakap tadi, gravitational force, and the pushing back is actually called the reaction force. The pushing back from the table is actually the reaction force. So tapi kita tak cakap it's the force from the table. Kita cakap reaction force, yeah, because it has contact with the table, therefore it has reaction force ataupun N ataupun capital R. Let me write that. So this is your R, this is your Fg, and if I'm pushing it to the side, this is just a recap, right? Benda ni semua kita dah belajar. I hope everyone is up to speed. If I'm pushing the box to the side, I can say this is a 10 Newton pushing to the side. Therefore, this box will experience friction on the opposing side. If my box punya motion is to the right, friction must oppose that motion. Always terbalik. Kalau letak friction kat sini, salah. You cannot have friction in the same direction as your motion because friction ni, tujuan hidup friction ni adalah untuk oppose motion. Dia akan menghalang benda tu bergerak dengan laju. So kalau kita letak dia selari dengan motion, then dia sebenarnya menolong. Dia menolong movement of that motion, right? So it has to be the opposite way. Itu objektif hidup dia lah. Okay, kalau korang letak sama direction, korang bagi dia sedih lah. Okay, sebab friction punya tujuan is not that. So friction always opposes the motion. So friction is this way. What else do we have? We have reaction, gravitational force, friction. We have tension. Tension only exists if there is a string. Okay, if there is a string. And what is the direction of tension? Always towards the center of the string. Let's say this is the center. Madam, this is not center. So from the center mass, this is my tension. Okay, and then we have the instances where the pulley is smooth. Kalau ada pulley kat sini, and there's a weight over here, therefore the tension over here is equal. So tension 1, this is also tension 1. Only happens if the pulley is smooth. Sorry, saya buat laju sikit sebab kita dah belajar ni. And what else? Okay, we talked about equilibrium of forces. Talked about equilibrium, forces in equilibrium. Okay, ni saya slow sikit sebab kita baru belajar. So when they say an object is, kenapa tulisan saya buruk sangat ni? An object is not moving, okay, or in constant velocity. Okay, not moving meaning your v is equal to 0. Constant v meaning the change in v is equal to 0 or acceleration is equal to 0. So these condition, condition pertama dan condition kedua ni bermaksud your object is in equilibrium. Okay, so from here, if we want to write an equation, we need to write it like this. Okay, write the condition first. So F net. Sorry, it's the zigzag thing is already net. So net of force is equal to 0. This is your condition. Net force in the X is equal to 0. Net force in the Y is equal to 0. So back to our example just now, we had a box on a table. Okay, and we had Fg down here, we had R over here, we had friction, and we had 10 Newton to the right. So if I wanted to find out what is my friction and find out what is my reaction, assuming that I know that my Fg is 20 Newton, I can use this condition to solve the unknown forces. So I started with my condition. This is your first step. Second step, write down equation according to your free body diagram. So in your Fx punya direction, so we have friction to the left minus F. We have 10 Newton to the right. So this is equal to 0. Okay, and then in the forces in the Y, we have reaction going up. And then we have Fg, which is equal to 20 Newton going down. This is equal to 0. So R, we can solve using this equation. R is equal to 20 Newton and your F is equal to minus 10 Newton. The direction is to the left because it has the negative sign. The direction is upwards, it has the positive sign. Okay, so this is how you use the equation if the object is in equilibrium. Now, moving on to our next example. This one. Okay, a crate of mass 50 kilogram lies on an inclined plane. So inclined plane, this is how the inclined plane should look like. So we have an angle. Find the maximum inclination. So it's asking, hey, what's the angle here? To keep the crate to stay at rest, V equals to 0 on the incline. Okay, coefficient of static friction is 0.25. Doctor, what is coefficient of static friction? It's mu S, 0.25. Okay, coefficient of kinetic friction is 0.2 mu k. Okay, so that is your information that you have from the question. So you have the 50 kilograms, saya lupa nak tulis. So you have a crate that is 50 kilogram. If I wanted to draw the free body diagram, I start from the center of the mass, always pointing down, FG ataupun MG. I prefer to write as MG. Okay, mg, because force equals to mg. Force equals to ma, your acceleration in this case is gravitational acceleration. So F equals to mg. Okay. Then we have, remember I told you about the inclined plane. We can resolve this mg into the x and also in the y. Why is our x and y this way? Because it's easier to resolve something that is in parallel and something that is perpendicular to our object. So object kita slanted, object kita sengit. So it's easier if we label our x-axis here and our y-axis here, or you can call it as parallel and perpendicular. Boleh, tak kisah. So nanti kan when you write the equation, you can write it as fx ataupun f parallel, or for your y, fy ataupun if you like perpendicular. It means the same thing. Alright, so that is your information. Now we want to resolve our mg. No, first we need to label all our forces acting here. So our crate is touching a surface, therefore it would have what force? Oh, I don't have coffee. What force would it have? Oh, I have 70 chats over here. R. Okay, Shaky is saying R. Okay, Shaky, tak boleh letak small r, kena letak capital R. Okay, so that is your upward motion. Your R must always be 90 degrees to the surface. So, kalau tengok kat sini, macam pelik je. R dengan mg ni macam tak sama exist kan? Memang macam tu. Mg is always pointing down walaupun objek sengit. R follow sengit-sengit tu. Dia follow the surface. Shafika is saying friction, F. So if our box is on a inclined plane, where would the motion tend to go? Would it be going to the left or to the right? To the right. Why? Okay, right. Everyone is saying right, but why? Kita kena make sense of this. Why would an object that we put on an inclined plane wants to slide off? Kenapa? Everything is about making sense, right? Sebab the tendency ada. Okay, the tendency comes from somewhere. What makes it tend to go downwards? Gravitational force. Okay, Feli is saying gravitational force. I would like to agree with Feli. Tapi kan Feli, gravitational force kita ke bawah. So macam mana tu? Sophia is saying inertia. Bukan. Lama pula saya nak jawab. Okay, Feli, can you explain more why you say it's gravitational force? Okay, kalau salah tak apa, just go for it. Saya mute korang ke?
Dia ada pulling force dekat center of the earth. So dia akan pull ke bawah. Macam tu.
Dia ada pulling force from the center of gravity?
Earth. From the earth.
Oh, from the earth. Okay. Okay, but the pull from the earth is here. This mg. Okay. So kat mana dia ke bawah tu? Betul, tapi it's what you're saying is correct, but kena detail lagi. So it's from gravitational force, but berat kotak tu is mg. Betul lah, everyone is like trying to make sense because ni benda yang kita nampak hari-hari tapi kita tak tahu kenapa dia menggelongsor kan. Okay, so sebenarnya betul, it's from gravitational force, but if we try to resolve our gravitational force, it would be mg sine theta over here. This would be our theta, and this would be mg cosine theta. So from our gravitational force, if we try to resolve it, we have mg sine theta pulling the box. That is from the gravitational force. We have mg sine theta pulling ataupun pushing the box downwards, and this is the component acting on perpendicular to the box. So we have mg sin theta yang tarik box tu ke bawah. Mana dia datang? Dia datang daripada mg. It's from gravitational force lah. So betul lah. Cuma not mg entirely. Only the component of mg acts to tarik the box. Okay? Faham tak? Does that make sense? Faham. Okay. Okay, so I'm going to repeat myself. I think this is a little bit confusing. So kita ada gravitational force called mg, right? But mg is pointing downwards. Dia tarik ke bawah, right? So apa yang menyebabkan box ni tertarik ke depan? So when we resolve our mg, kita tahu mg is force. Force is a vector. We can resolve it into the x and into the y. So apa yang menyebabkan force tu pull in the x-axis? So to find out the force that is pulling in the x-axis, we resolve mg and we find out that it's mg sine theta. And whatever that value is, that is the force that is pulling the box, not mg entirely. So let's say mg is 20 newtons. When I find out what is mg sine theta, it must be less than 20. Let's say it's 12. So only 12 Newton out of the 20 Newton mg is pulling the box because the rest is going down here. Okay. So nombor ni tak betul ni saya hentam je. Okay, so let me write that back. So bila kita ada mg, you need to resolve it, especially on an inclined plane. You have to resolve your mg so that you know what is acting in the x and what is acting in the y. So selalunya orang ada mg tapi dia lupa nak resolve, so salah lah. You can't solve your net force in the x and net force in the y. Okay, so I hope everyone is clear on that. That is mg cosine theta, this is mg sine theta. Saya resolve daripada mg. And then we have friction. Friction is opposing the motion. Sekarang ni gravity menarik dia ke bawah, maka friction akan oppose this. So this is your F. So macam mana nak tahu tendensi kotak tu bergerak ke bawah ke atas ke? Look at your mg. Resolve your mg first. Where is the force acting? Then only label your friction because gravity memang akan tarik something. So gravitational force must be greater than, Molly cakap gravitational force is greater than mu mg sine theta ke? Molly, kamu ni orang Kedah kan? Kedah. Oh no, Sarawak. Okay, sorry, tertukar. Okay, patutlah awak cakap macam tu. sorry. Tertukar dengan orang lain. Okay, so Molly is asking, Fg needs to be greater than mu mg sine theta ka. Just kidding, ka tu tak ada dalam equation. So Fg greater than mu mg sine theta, right? Okay, so let's look at this. Fg is going down. Why does it need to be greater than mu mg sine theta? Mg sine theta is in the x. So macam mana ni? It's not in the same axis. So kita tak boleh compare. Kita hanya boleh compare forces yang sama axis. Remember, vector selalu kena compare satu axis sahaja. Tak boleh berbeza. Kalau Fg is in your y, Fg is in this direction. Mu mg sine theta is your friction. Okay, assuming this is what Molly is saying. Molly is saying this is friction. Tak boleh sebab Fg ni arah berbeza dengan friction. Okay, one more thing. Molly say mu mg sin theta for friction. Okay, friction punya equation is mu r. What's your r here? What is your r here? Molly assumed it's mg sin theta. Is it really that? Mg cosine theta. So, okay. Okay, betul-betul. Mg cosine theta. Okay, macam mana dapat ni? Okay, let me explain. Okay, let's do this. Saya tulis lawa-lawa sikit lah. Oops. So this is mg cosine theta, mg sine theta. Okay, so is this box flying? That's my first question. Is this box flying? It's not flying. Saya bagi tahu jawapan. Kalau korang tak perasan lagi lah. So F net in the Y is equal to 0. Why? It's not flying. So tak ada acceleration up, tak ada acceleration down. It is in equilibrium. Therefore, it is equal to 0. Tengok box ni kan, box ni bergerak ke kanan ke kiri je ataupun tak bergerak ke kanan sahaja. Doesn't go up, doesn't go down. It's on the surface, it's touching the surface. So there's no acceleration pushing it up, there's no acceleration pushing it down except for gravity lah. So we can say that this box is in equilibrium in the y-axis. So net in the Fy is equal to 0. So I can write this R positive minus mg cosine theta. This is equal to 0. I'm only equating things ataupun forces that is in this axis only. Yeah? Then I try to solve it. R equals to mg cosine theta. We know what is our mg. This is 50 times 9.81. And we don't know what is our theta. That is our R. Okay, so if we wanted to write down friction, therefore friction would be mu R, and mu is 0. Either 25 or 0.2. We are assuming it's not moving because it has to stay at rest. So kita akan pakai mu S. Itu soalan dia cakap. So 0.25 and R is this guy. So 59.81 cosine theta. Theta kita masih tak tahu apa. Okay, so that is your friction. Macam mana kita tahu reaction force? We got it from our F net in the y-axis. Now we look at our F net in the x-axis. Adakah kita bergerak? Adakah my net force in the x equal to 0 or not? What's your guess here? Cuba tengok soalan. So Feli is saying the F net in the x is equal to 0. Betul? Sebab look at the question. A crate of mass 50 kg lies on an inclined plane. Find the maximum inclination. It's asking us to find the theta to keep the crate at rest. Maksudnya tak bergerak lah. So Fy memang dah tak bergerak lah. So our Fx is also equal to 0. This is the condition of the question. So net in the Fx is equal to 0. And then we find out what are the forces in this axis. This axis sahaja. Jangan campur-campur. Okay, so let me write that down. So we have mg sin theta. This is positive, this is negative. Mg sin theta and minus friction, which is 0.25, 59.81 cosine theta. Mg kita tahu apa, we can substitute that inside here terus. So this is 59.81. Theta tak tahu, and this is equal to 0. Okay, so can we solve for theta using this equation? Or boleh ke tak boleh? Macam mana nak solve tu? Okay, let's do this together. curi tempat lah. Gendut ni. Sekejap. Kecilkan. Okay, harapnya korang masih boleh baca. What is this? Group. Okay, saya nak yang ni. Kita nak try to solve this guy over here. Hello. Kenapa dia tak nak ambil? Seketika lah. Okay, tak apalah. Dia tak nak cooperate. Terpadam je dia. Okay, korang dah tahu kan apa friction? Okay lah, saya tulis balik lah. So friction is equal to mu S R, and this is 0.25, 50, 9.81 cosine theta. So this is your F. Okay, so now we are looking at this equation. Kita nak try to solve for theta. So our unknowns here is sine theta and cosine theta. So using your trustworthy math, saya tak boleh percaya diri saya dengan math. You can solve this. You make the sine and cosine to become tangent. Ya, saya tengah cuba. Let's try this. So I bring cosine to the other side. Yeah, tangent is opposite over adjacent. Tangent is sine over cosine. Yes, sine over cosine. Is it tangent, inverse tangent? Is it sine over cosine or cosine over sine? I think it's sine theta over cosine, right? Betul tak? Google je lah, tak tahu. Is it sine? Kan. Cuba can someone Google? Tangent theta is equal to sine theta over cosine theta. I think it's right, but I'm not sure. So this is your formula, assuming it's right. Yes, okay, thank you. So this is your formula. So kita ada cosine dengan sine. Kita try to make it into this form. Okay, so this is our aim when we have something like this. So I bring this guy yang negative ni to the other side, so it becomes positive, 0.25, and this is 50, and this is 9.81, and this is cosine theta, and we have 50, 9.81, and this is sine theta. So we have an equation on the left and an equation on the right. 50 cancels out with 50, 9.81 cancels out with 9.81. So I bring this cosine to the other side, sine theta over cosine. I'm left with 0.25 is equal to tangent theta. So inverse tangent is of 0.25 will give me theta. Okay. So you get 14 degrees, 14.04. So theta is 14.04. Harapnya betul. So what did we do just now? Let's do a recap on this problem. So a crate of mass 50 kilogram lies on an inclined plane. Find the maximum inclination angle. It's asking what's the angle yang untuk bagi kita punya box ni tak jatuh. So box kita ni stay still. If kalau korang perasan, lagi condong something, lagi senang jatuh. So bila kita kebawahkan, ada certain angle yang objek kita ni bila kita letak, dia tak jatuh. Tapi bila kalau kita naikkan angle dia, dia jatuh. So kita nak tahu apa angle yang kita perlukan supaya box ni tak jatuh. So this is what we're doing. So that was the question. This is what the question is asking. So dia bagi kita dua coefficient of friction, coefficient of static friction and coefficient of kinetic friction. They give you two coefficient. It doesn't mean that you have to use all info. So it's asking you what is the angle to stay at rest. So you need to use your coefficient of static friction only. You don't need your coefficient of kinetic friction. Okay, this is your S, mu S. Okay, so we know that our box is not intended to move. Kita nak just stay at rest. Net in the Fy confirm equals to 0 sebab dia tak terbang. So net in the Fy equals to 0. What is in the y-axis is positive R minus mg cosine theta. Bukan mg. Mg is not in the same axis. So tak boleh masuk equation. Kita dah resolve, pakai yang resolve sahaja. So R minus mg cosine theta. Kenapa minus? It's going down. R is going up. So kita boleh solve for R. Tapi walaupun kita solve for R, we still don't know what is the angle. So we don't really know the magnitude of R yet. And then from R, we get our friction. Friction is mu s R. So we use the coefficient of static friction, 0.25. This is the info given, times with R. R is 50 times 9.81 times cosine theta. We still don't know what is the theta. Kita tengah cari. And then we know that this box is supposed to not move. Therefore, acceleration equals to 0. Therefore, it is in equilibrium. Therefore, F net is equal to 0. So this guy is equal to 0. So equation, apa forces yang acting dalam x-axis, tengok kat sini dalam line pink ni, we only have friction and mg sin theta. Again, mg kena resolve baru ada komponen in the x. So mg sin theta positive. So tulislah 59.1 sin, and then friction kita tahu daripada equation ni, letak balik kat sini. So 0.25 59.1 cosine, and then we just solve for theta. Habis cerita. Okay, ada soalan tak about this question? Is everyone okay? Did everyone get it? Oh, ada satu soalan kat website yang macam ni. Okay, that's good. Nanti boleh apply. Okay, faham everyone? Okay, no questions? We are okay?
Ya, Doktor.
Okay, alright. So that's good. Kalau ada soalan, boleh interrupt me as usual. Okay, next. Not yet this one. Kejap cari lagi soalan. Is the minimum horizontal force to stop? Okay, lagi satu soalan. Yang bukan daripada slide. Okay. One more. New slide. Okay, pasal inclined plane lagi, a box on an inclined plane. A 45 kilogram box is kept from sliding an inclined plane. Again, it's trying to stay at rest by a string parallel to the plane. Sekejap, lukis dulu. So this is your inclined plane, this is your box. Let's use this color. Okay. Ada string parallel to the plane. Okay. Parallel maksudnya selari lah. Plane dia ada string. Saya tak tahu string dia ke kanan atau ke kiri. Let's just assume it's here for now. So kita ada string This is called this black thing is a string. We use the red one lah. So nanti kita nak buat free body diagram pakai black. So the coefficient of friction is 0.2. So dia bagi mu saja, dia tak bagi tahu S ataupun K. So you just use that. Mu is 0.2 and the plane is 50 degrees to the horizontal. 50 degrees to the horizontal. Okay. So this is equal to 50 degrees. So bila dah buat equation nanti dah tahu dah lah theta apa, boleh terus cari magnitude dia. So let me just label this as 50 degrees. What is the tension of the string? Okay, a 45 box is kept from sliding an inclined plane by a string parallel to the plane. So maksudnya kat sini, the string is trying to prevent the box from moving. So dia tarik lah kiranya. So dari segi logik lah, box kita akan slide ke bawah. So kalau kita ada string, string tu mestilah dekat sebelah yang tak menggelongsor kan. So this would be our string over here, and we need to find out the other forces that is happening on our box. Faham ke kenapa tension is on this side? Do you guys get it? So it wants to prevent the box from sliding off. So logically kita akan letak string kita dekat atas lah, sebab box ni punya motion nak ke bawah. Okay, ni ikut logik saja. Saya tak tahu betul ke tak. Hopefully it's correct. Okay. So we have tension here. This is what we declared. What forces do I have for this box? The typical one, mg, right? Mg. What else do I have? R, okay, R, what is the condition for R? Must be 90 degrees to the surface, perpendicular, yes, perpendicular to the surface. This is your R. Now we have a string. Where is my friction happening? Is it to the right or to the left? To the left. So Safa is saying to the left. Soh is saying to the left. Kenapa? We have a string over here. Does it change anything? It needs to oppose the motion. Yes, correct. So your friction is still in the same direction as your tension, walaupun ada string kat situ, because our motion punya tendency is to the right. So that is where our friction will happen in the opposite direction. So this is T, This is T and this is friction, and we are assuming that the box will slide off the inclined plane, so friction kena oppose. Now we resolve our motion, our gravitational force, because this guy is not in our axis yang kita nak. So our axis that we like is this guy, and in this direction, this is the axis that we want. So mg is not in that axis, so we resolve it. So let me resolve that in black. So this would be mg sine theta, this would be theta, and this would be mg cosine theta. Okay, so the one that is, macam mana saya cakap? Korang kena ingat lah position theta ni macam mana. You can resolve it using geometry, but I don't remember how to do it. So nanti hafal je lah, ataupun you can do it yourself. So if your angle is this way, it must be sandwiching, the angle must be in between the x and the mg. Selalunya macam tu. Okay, so we have mg sine theta and mg cosine theta this way, and it is kept from sliding, therefore acceleration is 0 in the y, acceleration is also 0 in the x. So that is our condition. Let's start with our Fy equals to 0 because it's not flying. So we have R positive minus mg cosine theta. And this guy is equal to 0. Mana datang 0 ni? Datang dari sini lah. We are writing the Fy equation. Okay, and then we know what is mg cosine theta. R is equal to 45, 9.81 cosine 50. Okay, don't know what that is. Can someone calculate that for me? And then net in the fx is also equal to 0 sebab kita nak dia stay at rest. It's kept from sliding. Acceleration equals to 0. Therefore, F net is also equal to 0. So what is in your x-axis? Your positive is mg sine theta, negative F, negative P equals to 0. Okay. Okay, so now we know what is our mg sine theta. Let me just put in the values. 9.81 sine 8, sine 50. Friction, kita lupa nak kira friction. So friction is mu r, 0.2 r is this guy, whatever that is, 45. Nantilah kita letak R. Ada orang dah kira R tak? Someone tell me what R is. Anyone? Oh, I need coffee. Oh, ada orang dah bagi tahu. Kejap. So it's 283.76. Wah, cemerlang. Okay, thank you so much everyone. So 283.76 Newton is your reaction force. So kita boleh terus masuk kat sini. 283.76. Can someone calculate friction for me please? Darab dengan 0.2. Bagi 5. Anything. Come on guys, berapa? Saya malas nak kira ni. 56.75. Yay, thank you Haris. 56.75. 56.75 Newton. Okay. So 56.75 is your friction. Okay, we don't know what our T is. Do we know what is our mg sine theta here? Yes, it should be. So apa jawapannya? 338.17. Yay, thank you. So 338.17 minus 56.75 minus T equals to 0. So you can solve for your T easily. So T is 281.42. Thank you, Sophia. Newton, this is your final answer. Okay, so kita dah dapat semua jawapan ni. Let's try to make sense of it. So what is going on here? So we have R is equal to 283.76. mg cosine theta is 45. 9.81 cosine 50, which is the same, 283.76. So 283.76 going up, 283.76 going down, they cancel out each other. Force, net force is equal to 0, therefore you don't have any acceleration. Acceleration is 0. R is balanced out by mg cosine theta. We have the same value. That is why they don't move. So now let's look in the y. So we have mg sine theta to the right. It needs to be balanced out with t and f. So the summation of f and t should give me mg sine theta. Tadi kita kira, bukan saya kira, tadi someone kira mg sine theta is 338.17 and friction is 56.75. So 56.75 tambah dengan tension, which is 281.42, should be equal to 338. This guy is equal to these two guys, baru diorang akan cancel out with each other. Therefore, they will stay still. Acceleration is equal to 0. Okay, kalau diorang cancel out the forces, kenapa acceleration equals to 0? F that is equal to 0. Remember equation F equals to ma. If your net force is equal to 0, therefore your acceleration also has to become 0. Your mass cannot be 0. Tak boleh jadi 0. Mass is mass. Mass is a scalar quantity. Your mass cannot be destroyed, right? So the only thing that can change if your force is 0 is just acceleration. So if F net equals to 0, your acceleration is 0. It's not moving. Ataupun it's in constant velocity. Tapi dalam case ni, it's not moving lah. Okay, any questions about this example before I go into non-equilibrium situation? Ada soalan tak? Faham ke semua orang macam mana nak buat free body diagram? How to write the equations? Why we use the condition of F net equals to 0? Kalau ada soalan boleh tanya. Sebab kita akan move on to the next one, which is macam level up sikit lah. Doktor, kenapa fx equals to 0? Okay, kita boleh cerita pasal ni. Any other questions selain question Afifah ni? That's a good question. Kalau tak faham boleh tanya. Okay, so just that question. Alright, so Afifah is asking kenapa net in the x is equal to 0? Okay, so kalau nak tengok soalan ni, so dia cakap a 45 kg box is kept from sliding. If I translate this, a we have a, cakap bahasa Melayu, 45 kg punya kotak, dia dihalang daripada menggelongsor. So kalau kita ada gelongsor kat macam ni, box ni dihalang dari menggelongsor. Dia tak nak dia box ni menggelongsor. So dia cakap okay, duduk diam-diam. Duduk diam kat sini. So kalau dia duduk diam, it's not moving, it is at rest. Therefore acceleration is equal to 0. Okay, is everyone following me so far? Dia duduk diam maksudnya acceleration kena kosong kan? Sebab dia tak bergerak. So bila acceleration equals to 0, your F is also equal to 0 because F is equal to ma. And if your A is equal to 0, your F is also equal to 0. We are specifically talking about dia tak bergerak menggelongsor. Menggelongsor ni X axis kita. Kalau dia tak menggelongsor, dia duduk diam-diam dalam X axis, maka acceleration in our X axis is also kosong. Therefore, our Fx is also kosong and F net in the X is also kosong. So this is the condition untuk bagi dia tak menggelongsor. Net in the Fy pula, we know that our box is not flying or it's not terbenam ke apa ke, it's just on top of the surface. It's not moving with respect to the X, it's also not moving with respect to the Y. Dia tak gerak, dia stay. So dalam Y axis, which is this way, AY is also kosong. Therefore, net in the Fy is also kosong. So this is the condition that you were using. Kita kena define condition ni dulu baru kita boleh start buat equation. Tak boleh tak tahu dia kosong ke, dia A ada value ke. Kena tahu dulu dia equilibrium atau tak, baru boleh tulis equation. Faham ke Afifah? Faham ke everyone?
Faham, Doktor.
Okay, faham
Faham,
Okay.
Doktor. Clear.
Boleh tanya. Okay. So next, kita akan go for object in linear motion. Okay, for an object not in equilibrium. What time is it? Okay, first of all, let's take a 5-minute break because we talked a lot. I talked a lot and korang belajar banyak. So let's take a 5-minute break. Let's come back at 3 p.m. Sekejap je break ni. Kalau soalan boleh tanya. Okay, semua. Doctor, why? So dah tanya dah soalan yang saya dah warning semua orang jangan tanya. So kena rotan diri sendiri. So coefficient of friction bermaksud, oh sorry. So tanya yang bermaksud, bukan tanya apa. Coefficient of friction ni bermaksud kekasaran permukaan tu. Sekejap, let me get my breath. Tadi saya naik tangga. Baru nak suruh rotan diri sendiri. No, daya geseran is friction, force. Mu is coefficient. Betul. So kena rotan diri sendiri. Dia tak tahu mu tu apa. Okay, so awak hutang rotan Okay, gurau je. So mu is the coefficient of friction. So bila kita cakap pasal friction, F equals to mu R. This guy is your coefficient of friction. Okay, R is your reaction force. Coefficient of friction tak ada units. Therefore, if your reaction is in Newton, your friction is also in Newton. So kalau reaction is in other units apart from Newton, maksudnya salah. It has to be in Newton. This guy is in Newton. This guy is in Newton. This guy no unit. That's why it's the coefficient. Coefficient ni memang selalu tak ada unit. Coefficient ni macam macam apa nak cakap. Kalau dalam bahasa Melayu namanya dia pekali rasanya. Pekali. Kenapa saya tak nampak soalan so? Sebab dia tanya senyap-senyap. Dia takut kena rotan. Okay, next. Faham Mu ni coefficient of friction. Apa maksud dia? It's kalau lagi kasar permukaan tu, the coefficient is greater. Coefficient tu besar lah. Coefficient tu jadi, let's say kita cakap pasal jalan tar. So jalan tar akan ada coefficient of friction 10. Lepas tu saya cakap apa coefficient of friction tablet saya yang saya lukis-lukis ni. Dia licin kan? So coefficient of friction permukaan tablet ni adalah 0.25. It's just a factor to tell you how kasar it is, how kasar a permukaan is. Sebab lagi kasar, lagi tinggi friction. Okay, so dia bagi tahulah dia macam ikut surface lah value dia tu. Ada table dia. Okay, next. Doktor, kalau box tu gelongso with constant velocity dikira equilibrium tak? Yes, dikira equilibrium. So equilibrium condition ada dua. Satu is V equals to 0, bermaksud A equals to 0. Satu lagi change in velocity is 0, bermaksud velocity constant. Yang ni pun A equals to 0. So dua-dua ni adalah equilibrium. Bila kita cakap pasal equilibrium, kita cakap pasal acceleration equals to 0. Bukan cakap pasal velocity, kita cakap pasal acceleration. Okay, next. Soalan, banyak pula soalan korang Doctor, why the G at projectile motion is negative but at here the G is positive? Okay, that's a good question. Dalam projectile motion, kita tak ada, saya cakap, kenapa G positif? Ke mana? 2 equals to minus 2. Kita punya G negatif lah. Kenapa G kita positif? Kat mana positif tu? Can you tell me where the equation where G is positive? Tapi saya pernah dapat soalan yang sama. Tapi saya tak faham kenapa korang cakap yang tu positif. Kat mana korang dapat G positif ni? Bila kita buat V square equals to U square plus 2AS contohnya. 2AS and we are talking about Y axis punya projectile kan? Projectile ada Y axis. So this guy becomes V squared U squared plus 2 minus 9.81. Was it? It's minus, right? 2AS. Was it positive? Minus kan? Okay. Next. So If the question didn't mention either it's static or kinetic, how do we differentiate it? Okay, kalau soalan tak kata apa-apa, you just use the coefficient given. You don't have to assume it's static ke kinetic ke, just use the coefficient given lah. Kalau dia cakap pasal moving, the box is moving, you use the kinetic coefficient. If the box is at rest, you use the static coefficient. Itu pun kalau diberilah. Kalau dia bagi satu value je, just use that. You don't have to worry about that. Okay. Oh, sorry. Saya baru faham soalan Feli. Feli tanya, Doktor, why is G at projectile motion is negative? Betul lah. And why the G here is positive? So, sorry, terbalik tadi. Okay. Saya faham dah. Okay. Okay, so kenapa G kat sini positif kan? Okay, that's a good question. Kejap nanti kita go back to that. Coefficient untuk stylus rendah, betul. It has to be smooth. If not, rosak lah kan. Okay, dalam calculation 9.1 tak ada negatif. Okay, faham. Saya dah faham dah. Okay, saya cerita balik kenapa dia positif kat sini. Okay, saya yang salah faham soalan Feli tadi. Sorry. Okay, mana gambar tadi? Oh, it's here. Okay, mana tadi negatif kita positif. Okay. Kalau tengok kat sini, kita punya R and then mg cosine theta, right? So mg cosine theta, saya punya equation saya cakap M is 50 kg, G is 9.81. So kat sini tak ada negatif tu, right? And then cosine theta. Tapi bila saya tulis equation, saya kira R going up, mg going down. It's negative here. So kalau saya cakap minus G kat sini, then this would become minus, so it's a positive. Therefore, the force is not going to be acting downwards, right? Tapi kita nak cakap mg ni terbalik dengan R. So kenalah ada negatif ni and the G should be positive. So soalan dia kat sini, kenapa kita letak G as positif? Kenapa tak letak as negatif je? Boleh kita letak as negatif. Tapi bila kita projectile punya motion, we didn't have the free body diagram, right? We just immediately went for the calculation. So when we immediately go for the calculation, we had to determine the direction ourselves, which is G is a minus. Okay, let me repeat myself. Dalam projectile motion tak ada free body diagram. Kita tak start free body diagram lagi. So kita terus go for equation. Dalam equation, kita tak tahu direction because we didn't have FBD. We didn't have the free body diagram. So kita kena say that G is a negative. G is going down. Dalam free body diagram, the arrow is already going down. So if I put it into my equation, I already know this is a negative. So I don't have to put the G negative dah lah. Okay, so faham tak? Negative tu ada, tapi it's in the free body diagram in the form of an arrow. So when I put it into this equation, it's still a negative. Walaupun kita cakap G tu positif. Faham Okay. I'm going to repeat myself again untuk orang yang blur. Kenapa projectile motion pakai negatif G? V squared U squared plus 2 minus GS. And in this case, I wrote the 9.81 as positive. Kalau tengok sini, positive 9.81. Positive 9.81. Positive 9.81. Because kita punya equation comes from the free body diagram. Free body diagram dah ada direction. So we just follow the direction of the free body diagram. I don't have to declare that the 9.81 is negative because I already know it's going down based on the free body diagram. So when I put it into my equation, the negative is there from the free body diagram. So let's say saya tak pakai free body diagram and I wanted to use this equation. I would have to declare the G is negative. So macam ni dia akan jadi R plus mg. Oh, G is a negative. So M minus 9.81 cosine theta. It's still the same thing. R plus M minus 9.81. This is because I'm not following the free body diagram. It's not following the free body diagram, which is what projectile motion buat lah. Dia terus pakai equation. Kat sini kita ikut free body diagram. So the negative comes from the diagram. Okay, I hope everyone is clear on that. Jangan confused dah. Okay, free body diagram tak perlu negatif untuk G dia. Ikut arrow gambar. Projectile motion, declare G as minus 9.81 because we don't have the free body diagram. Okay, yang ni akan jadi minus. Okay. Okay, any other questions before we move on? Doktor, memang semua soalan fizik HOTS ke? Pening saya fikir. Tak, ada je soalan senang. Macam definition, soalan definition is not HOTS. HOTS ni apa HOTS ni higher order thinking skill. Panggil apa? Akibat tak tahulah. So HOTS ni HOTS, soalan fizik mostly HOTS tapi ada je soalan definition, ada je soalan konsep yang tak perlu kira-kira, konsep yang mesti biasa je, tak susah sangat. Saya rasa lah. Tapi ada je, dia tak adalah semua. Okay, so don't be too worried about it. As long as you understand what we are doing in class, it should be fine. Okay. Okay, so kita move on to the next subtopic, 3309. Okay. Okay. So previously, the examples that we talked about is an object not in equilibrium. An object in equilibrium. Maksudnya A equals to 0. Equilibrium maksud dia A equals to 0. Tak kisahlah A tu 0 macam mana. A equals to 0, tak kisah A tu macam mana, asalkan 0. So A akan jadi kosong bila change in V equals to 0 ataupun V equals to 0. Aim kat sini, equilibrium A equals to 0. Ini adalah kondisi dia, condition dia. Okay. And dia tak kisah macam mana dia capai A equals to 0 tu, asalkan A equals to 0. That is equilibrium. Now we go on to non-equilibrium motion. For an object not in equilibrium, A is not equal to 0. So tak kisah macam mana dia dapatkan A is not equal to 0 tu, asalkan A is not equal to 0, confirm not in equilibrium. So the net force must be in the direction of motion. Net force must be in the direction of motion. Kita ada net F that is equal to, kita punya net F ni ada X dengan Y. So it has to be A ataupun F net in the Y is equal to A. Tak tahu dia gerak atas ke, dia gerak ke kanan ke. So it depends, dia bergerak ke mana, that is your A. Kalau dia tak bergerak, dia tak terbang, this guy will still be 0, but it's moving to the right. So you would have F net in the X equals to A. Nanti kita akan tengok. Okay, so the different types of acceleration lah for the net force. From Newton's second law, F net equals to ma. The net force acting on the object must be in the same direction as the direction of motion. So kalau acceleration is to the right, then your net force is also to the right. If your acceleration is going up, then your net force should be going up. Okay. So kalau acceleration is negative, then F net is negative. Dia ikut sebab dia vector. Okay, and then ini saya conteng. Okay, for an object not in equilibrium, the net force is in the same direction as the direction of motion. If forces are in 2D, then you would have Fx and also Fy. So kat sini dia cakap Fy is equal to 0 sebab tak terbang, and sum of parallel components ataupun Fx equals to ma. This is we assuming that it is moving in the x-axis. Motion adalah dalam x-axis. Okay, so ini tak payahlah, ni data sama je macam tadi. So let's take a look at an example. Yang ni tak payah lagi. Let's do, okay ni susah sikit. Buat yang senang dulu Kita buat ni, example 3.6 dulu. Duplicate slide. Okay, so a 15 kilogram box is released on, kenapa dia tak explain sangat lah? Oh tu je the explanation dia. So a 15 kilogram box is released on a 32 incline. Soalan incline lagi. So incline is the favorite here. And accelerates down the incline at 0.3 meter per second squared. So the acceleration adalah ke sini. Let me write it in, let's use this guy. Oh, tak nampak pula. The acceleration is this way. A equals to 0.3. Dia cakap accelerating down. So motion adalah ke kanan. Ke kanan bawah incline. Find the friction force impeding. Impeding maksudnya yang menghalang. Its motion. So motion adalah ke kanan. Therefore, friction must be opposing the motion. So we have a box here. Dia tak terbang Kejap, saya buat padam balik. It's not flying. So it should be touching the incline. Okay, so that is our box. Draw. Okay, so we have our mg macam biasa. Mg should be downwards. Buat besar sikit. Acceleration is not part of our free body diagram. Free body diagram hanya referring to forces. So acceleration kita boleh label macam ni but not on the object itself. So we have mg. We know that we will have friction trying to impede the acceleration. And then we know what is the mass. Mass is 15 kilogram. Acceleration is 0.3 and it's trying to go down. Okay, so now I want to try to resolve my forces. Am I missing any other forces here? Bagi korang berfikir sikit. Sebab petang-petang ni kan. R, yay, it's R, correct. So R is perpendicular to the surface ataupun apatah tadi ayat, I think Sophia mention menegak dari surface, saya tak ingat. But ada ayat dia, it was interesting to me. So R adalah perpendicular to the surface, friction must be opposing the motion. Motion adalah ke kanan, saya label dengan this grey crayon ke kanan. We have mg. Now I want to resolve my mg because we want everything on the axis. So mg is not on our axis yang kita suka, so kita akan resolve. So mg sine theta. I always forget to label this. So this is theta. Mg cosine theta. So apa kita nak buat dengan kita punya acceleration ni? So we write the condition. Is my box flying or not? Is it trying to fly? Does it have the tendency to fly? Boleh ke box saya tiba-tiba nak terbang?
No.
Unless this is Haikal. But this is not Haikal, it's a box. So tak boleh terbang So our A in the Y is equal to 0. Sorry Haikal, main-main je. Lepas tu kita tulis equation semua yang dalam Y. So R positive minus mg cosine theta. I have the negative here, so I don't have my G punya negative. So I don't really need the negative G here because it is given by my free body diagram. So this guy is equal to 0. It is in equilibrium walaupun problem kita ni non-equilibrium. The Y axis is in equilibrium, it's not trying to fly. The box is not flying. So this is our equation. Next, Fx, is it equal to 0 or not? No. Doktor nak kata Haikal angel ke ni? Bukan saya, Amy yang cakap. Oh, everyone is saying no to Haikal being an angel. Sorry Haikal. Okay, just kidding. Korang cakap No to the fx. Okay, so fx is not equal to 0, right? So it has acceleration in the x. So therefore, my equation cannot be equal to 0. It has to be equal to something, but it's not 0. So it must be ma. What is the m? The m is the box because we are talking about the forces acting on the box. So ma is equal to, box is 15 kilogram, acceleration is to the right. I'm going to assume this is my positive side. So it is 0.3. So this is my force in the x. 15 times 0.3 is 4.5. Okay, so you know that your net force in the X is 4.5. Tapi kita tak tulis lagi equation forces kita dalam X. So we can write that now. So 4.5 equals to positive mg sine theta minus friction. Dia akan equal dia tak masuk dalam belah sini. So it's your condition. You started with condition Fy equals to 0. And then untuk equilibrium condition, you started with net in the Fx equals to 0. Here, your condition was net in the Fx is equal to ma. What is ma? M is mass of the object, 15. And the acceleration was given as 0.3. Lepas tu dah solve yang ni, that is the condition. What should be in your equation? So mg sin theta minus f. This is equal to the condition of 4.5 Newton because that is the force. So dari sini kita boleh solve for f. So mg is 15, g is 9.81. Sine theta is 32, sine 32 minus f. This is 4.5. So you can solve for friction. Tak habis lagi cerita dia. Cerita dia tak habis lagi. So friction is entah. Can someone calculate this for me please? I need someone to double check my answer. 15 times 9.81 times sine 32 minus 4.5 dapat 73.48. Betul ke? Newton. Okay. Soalan tanya, what is the coefficient of kinetic friction? So we have friction force, but we don't know what is the coefficient. It's not given. So the equation for friction is mu r. So to find mu, we need to know what is r, which we can find from this equation. So friction kita tahu 73.48. Mu is unknown. R we need to find out. So R is equal to 15, 9.81 cosine 32. What is that? Ada orang dah jawabkan ke? 124.79. Thank you. 124.79. So this is 124.79. Therefore, your mu is 73.48 divided by 124.79. 0.59. Sama tak? Tengok sekejap. Okay, 0.59. Thank you. So you get your mu as 0.59, which makes sense because kita punya mu ni selalunya below 1. Kalau yang more than 1 ni memang kasar lah. Selalunya kita punya mu is below 1. Logically. Okay. So that is how you use the condition bila it is non-equilibrium. I'm going to repeat myself here. So here kita punya box, it does not have the tendency to fly. So our F net in the Y is equal to 0. So our net in the Y is still equilibrium. Dia tak bergerak. Tak ada motion atas bawah, tak ada. Tapi ke kanan ada motion. We have acceleration. Therefore, the net in my Fx is equal to ma. What is the mass in this case? It is the object yang kita lukis di body diagram ni lah. So the mass is 15 kg times the acceleration yang dibagi untuk motion. So this is 4.5 Newton. This is the net force. So The equation for my net in the x is mg sine theta minus f. So this is your equation. You equate it to your condition. Yang condition dapat daripada MA tadi. Lepas tu solve macam biasa. Okay, tu perbezaan antara equilibrium dengan non-equilibrium. Any questions about that one? Sekejap. Tengok soalan yang senang sikit dulu before kita go for harder ones. Okay, let's try this one. Okay, ini soalan exercise. So I want everyone to try this one. Kejap Not this one. New slide. Okay, please try this one. Yeah. A crate of mass 50 kilogram is released from rest. Okay, so discuss dulu. U equals to 0 here at the top of an inclined plane. Dia touching buruk sikit. Lepas tu, if the coefficient of friction is 0.2, dia tak specify kinetic or static, so you just use it as it is, 0.2. The length of the plane is 3.5, so S equals to 3.5. Distance kalau box ni daripada atas ke bawah, dia bergerak, so I'm just going to call that as S, 3.5 meter. And the angle of the incline is 30. Calculate the speed of the crate when it reaches the end of the plane. So, mula-mula box ni ke atas, dia slide with some acceleration and then dia nak tahu what is V. Kita tahu U dia apa, kita nak tahu V. But before we can solve for V, we need to know what is A. Macam susah kan? Tapi sebenarnya tak. Okay, so the first step to this guy is first drawing your free body diagram and try to solve for the acceleration. Tak payah fikir pasal nak jatuh lagi ni. Solve for the free body, draw the free body diagram dulu lah. Okay, so padam dulu. Abaikan U dengan V ni. Kita tahu ada acceleration. U and V berbeza, therefore we have acceleration. So just leave it at that. We have some acceleration. We don't know what it is yet. And daripada acceleration ni, kita akan dapat V from our U. U is equal to 0. Okay. Free body diagram, mg, going down. Saya tahu, I know I'm asking you to do this, but saya takut korang blur. Kita start dulu. So we have R. Okay, so R is this one. Mg is this way. What is the mg acting here? What is the mg over here? I shouldn't write it down. Okay, and then we have friction. Does it have friction? I forgot friction. Yes, we have friction. Okay, so we are assuming that it's going down, right? From the problem, it says that it's going from the top to the bottom. Therefore, the motion is to the right. Motion A. We have acceleration. Okay, we have friction, we have reaction force, we have mg. Ini macam tak berapa cantik. R. Sama je. This is some angle. Okay, what else? Coefficient of friction is 0.2, length of plane. Okay, you guys try to solve for the F net in the X, F net in the Y. First, I'm going to call people as usual. And then baru kita akan go for what is the speed at the end of the crate. Itu saya akan buat sama-sama, okay? But I want you guys to know how to write the equation first using the free body diagram. Okay, I'm going to give everyone 7 minutes to do that. You can discuss, you can ask questions. 7 minutes, eh? So 3:34 p.m. Look at this free body diagram, write your equation. Start with the condition, then your equation from the free body diagram. Where is my panggil siapa eh? Okay, saya nak panggil siapa eh? Luqmanul Hakim. Luqman for net in the fx and then Shafiqah for net in the fy. Okay. So Luqman, Shafiqah. The rest of you get ready juga because if they don't get it, I'm going to ask you guys to answer. Kita dah buat banyak sangat example, so you should know how to write the equation by now. Let's see. Okay, I hope everyone got it. Syafiqah dah ready ke? Syafiqah? Walaupun tak habis masa lagi. Percaya tak tulis equation?
Doktor, Fy equal to 0 kan?
Dia tak terbang.
Dah.
Okay. Sekejap. Fy. Fx nanti Luqman. Okay. Net in the Fy is equal to 0. Okay. So what's your equation, Syafiqah?
R minus mg cos theta.
Cosine theta. Okay. And solve R for R.
R equal to 15 times 9.81 cos 30.
Okay. What's your answer?
R equal to 127.44.
0.44.
Yeah.
Okay. Thank you. Okay, Luqman. Net in the FX. Luqman. Doktor, kita kena cari ke masa dia? Tak ada kan? Dia tak suruh kan? Adam is asking, do we have to find the time? No. We don't. Luqman, are you there? Oh, Luqman. Luqman tidur ke? Where is Luqman? He is missing. MIE. Okay. Okay, so Luqman is MIA. Kan dekat kantor. Can we have someone else? Amirul Faiz. Ada tak? Amirul Faiz? Yang kata MIA juga. Amirul Faiz, are you there? Tak ada, okay. Oh, dia check sekejap. Oh, calculator rosak. Okay, tak apa. What is your equation? Kita nak equation je sekarang ni.
MA.
Okay, Fx equals to MA. Okay. Lepas tu? Oh, sorry. Tutup. Sekejap. Hello?
Yes, ni 15 darab 0.2.
15 darab 0.2.
Berapa ya?
Kenapa 0.2?
9.81.
Kenapa 9.81?
Sebab A kan?
Tapi ni A in the X. Okay, let's say A ni unknown lah. Saya letak A ni as unknown. So A is unknown. So what is your equation for your Fx? Condition kita adalah 15A. Okay, equation awak? Equation pakai free body diagram apa?
Cos F sama dengan kosong. Okay.
Bukan. Sekarang ni condition awak, kita ada motion. So we have acceleration, right? We have acceleration to the right. Therefore, kita punya condition is MA, betul. Tapi A kita bukan G. Kita punya acceleration is not equal to G. Kita nak cari acceleration tu. So sekarang ni tak apa, kita biar dulu. What is your equation untuk daripada free body diagram?
cari A guna equation V sama dengan U plus A T.
Bukan. Saya nak tahu equation yang kita patut tulis daripada free body diagram.
Maksud doktor?
Maksudnya free body diagram saya ni ada friction, ada reaction, ada mg. Apa yang saya patut tulis dalam equation saya based on free body diagram?
Oh, Fx tu P tolak F kan?
T tolak F.
T.
Apa? A ke T?
P.
P tolak F. Mana datang P?
P tu yang saya sangat clueless ni.
Okay. Ni
Terus.
tidur Okay, tak apa saya explain. So we have mg, right? When we have mg, kita resolve dia. Kita kena resolve dulu. So this becomes mg sin theta. Ini bawah ni jadi mg cosine theta. Okay. So saya dah bagi hint dah ni. Boleh tak awak bagi saya equation dia? Apa yang dalam x-axis kita? Ni x-axis kita, Amirul. Kan? Nampak tak? Ini kan? Okay. So apa yang saya patut letak dalam equation saya? Oh. Mana Amirul?
MC theta
mg sin theta, betul. Lepas tu?
M tolak F.
Betul. Tolak F. mg sin theta tolak F. Sebab kita nak apa yang ada dalam x-axis sahaja. Macam mana saya nak tahu apa yang dalam x-axis? Saya kena resolve apa-apa vektor yang bukan dalam axis supaya vektor ni dalam axis lah. Dan tadi mg kita bukan dalam axis x, bukan dalam axis y. So saya kena resolve dia supaya saya tahu semua kena dalam axis lah. Baru kita boleh masuk dalam equation. Okay. So Amirul, stay with me. Kita punya net in the fx is MA. M is 15 kg, betul. Sebab kita refer to this object which is 15 kg. Itu betul. And then awak cakap mg sin theta minus f. Boleh tak bagi saya value mg sin theta minus f ni?
15 darab 9.81
Betul.
sin 30.
Sin 30 minus
F.
F is apa? What is F? Equation F apa? What is equation for friction?
Mu R.
Mu R. Okay, what is our mu? Coefficient of friction?
0.2.
0.2. Apa R kita?
Mg R. Mg cos theta.
Betul?
Yang tu, yang 127.44 tu.
Yes. 77.44. So F kita adalah whatever lah kan. So 0.2. Oops. 0.2 darab dengan 127.44. This is our friction. Okay, thank you Amirul. Faham dah ke macam mana nak buat?
Faham.
Faham Okay. So kita dah dapat ni value kat sini. Condition dia, equation ni ada condition which is 15A. Bolehkah kita cari for A?
Boleh.
Boleh kan? Okay. So pakai calculator je lah. So A would be, Amirul tak ada calculator, so I hope everyone else can help. So what's the answer? Afifah cakap dengan Feli cakap dengan Patricia cakap 3.21. Okay, 3.21. So A is 3.21. The unit should be meter per second squared. So tadi kita buat slow-slow dengan Amirul tadi. Harapnya semua orang dah boleh catch up. Mana yang blur tu dah faham. Kalau blur lagi kena buat revision tau. Okay, so kita dah dapat A. Macam mana kita nak tahu kita punya V bila kita sampai kat hujung plane ni? Okay, Feli is saying use V squared equals to U squared plus 2AS. Okay, let's try that. So kita ada U is 0. We started from rest. We have our acceleration from our free body diagram. Kita buat kita punya MA, kita buat kita punya equal to 0. So we got acceleration. So now we want to know what is the what is the V. We don't know the time. So Adam tadi tanya, perlu ke kita nak cari time? Boleh kalau nak, tapi tak perlu in this situation. We have our displacement. We have our S. So V squared equals to U squared plus 2AS. Sebenarnya boleh cari time is equal to, I don't know what the V is. We are trying to find the 0. So we're trying to find the V. Our U is equal to 0. This is 2. Our A is this guy that we got from Amirul penjawapan. 3.21 positive. It was going to the right. S is also positive. It's going to the right. 3.5. So 2S. So akan dapat V as something. So what is the answer for V? Tuan dah dapat ke? Tajulah korang ni bagus. 4.74. Okay, 4.74. My question is, what is the sign for V? Positive or negative? And kalau positive and kalau negative, kenapa? Balkis is saying positive. Safa pun cakap positif. Yan pun cakap positif. Okay, kenapa? Oh, so he's saying negative. Feli is saying acceleration. It's because of acceleration. Okay, betul. Tapi acceleration kita positif. Therefore, kalau acceleration positif maksudnya apa? To the right and our speed must be increasing. We started from rest, 0. Our speed must be increasing. Is increasing to 4.74 because acceleration is positive, which is 3.2, whatever. Yeah, velocity is increasing. Betul, kelajuan bertambah. Okay, do we have time? Yes, we have another 15 minutes. So kita go for one more question. One more question. This one. Kita go for elevator punya soalan. So soalan elevator ni pun famous. A boy of mass 35 kg stands on a weighing machine inside a lift. Lift atau elevator lah. So this is your elevator. So inside a lift. So he stands on a weighing scale. He stands on a weighing scale. Weighing scale saya bulat. And no, this is not mine. This is korang punya. So kita pakai skirt pula hari ni. So it's a girl. Oh, it's a boy. Sorry. Penat-penat saya lukis. Penat saya lukis skirt sekali the boy. Selalunya saya lukis boy. Okay, so this is the boy standing on a weighing scale. He is 35 kg. This wouldn't be you. You guys are not 35 kg. I hope you guys are heavier than this. This should be a small boy. Stands on a weighing machine inside a lift. What will be the reading of the machine while the lift is accelerating upwards? So it's saying A of the lift is 2 meters per second squared. And then B moving down at constant acceleration. Kita buat moving up dulu lah. Kita buat moving up. Kita buat moving up dulu. Let me duplicate this first. Duplicate slide. So saya ajar this chapter quite slow compared to my previous chapter. Hopefully everyone boleh catch up kan. Kalau ada soalan boleh tanya. Jangan malu tanya. So everyone will make mistakes at one point. So don't worry about it. Oh, sorry. Okay, to just tell you guys lah. Saya waktu saya belajar fizik waktu degree, saya tak ada asasi, saya terus buat degree. So when I did my physics during my degree years, I got a C. Ni macam kantorkan diri sendiri lah. I got a C. Okay, I'm not a physics major, I'm an engineering major. So physics was like foreign to me. And I'm sure it's foreign to you as well. Sebab first time belajar kan. So I got a C for my first semester. And then I repeated the SEM. And macam mana nak cakap? I did a lot of exercises lah. I did a lot of exercises. Saya cari sumber kat internet yang saya faham, because the lecturer that was teaching me physics, I couldn't understand what he was saying. It was very complicated lah apa yang dia cerita tu. And what I did was I went to YouTube and I learned dengan cara pengajaran orang lain. If what I'm teaching you doesn't work for you, it's okay. You go to another teacher online. Just asalkan faham. And you try to do the exercises yang cikgu tu buat sekali. Dengan harapan korang faham lah apa yang dia ajar. So if this is not working out, the class is not working out, you try to find other sources that will help you to understand. So this is what I did, and I did the exercises, and eventually I understood what was it about lah. Lepas tu, when I had that basic knowledge, bila saya nak advance my knowledge on physics in other parts, it was easier because my basic was already strengthened. So this is the basic for physics. If this is not working out, my teaching methods are not working out for you, please try to find other sources. Saya takkan rasa offended because my style is not for everyone. Some people punya style is not for everyone. Everyone cara belajar masing-masing, right? But we can't choose who is our lecturer. But if we find another lecturer yang ajar online, we can choose, right? So choose the one that makes you understand. Okay, saya tak rasa offended pun because obviously semua orang ada cara belajar masing-masing, and that's okay. Okay, so I got really bad grades and it was really hard for me. But when I tried to understand dengan cara pengajaran orang lain, it worked out for me. So hopefully that will work out for you as well. But I think everyone is doing okay so far. Hopefully, if not, then we need to talk lah, okay? So, and then I got A's lah after I got the C. So hopefully that will work out for you as well, okay? And then now I'm doing my PhD in something related to physics. So if you did poorly for the first time, doesn't mean you're going to do poorly in the future. So jangan give up on knowledge, even though you're not good at it, okay? Saya study kat UPM juga. Tapi saya punya degree was in US. Yes, physics is hard. Saya pun rasa susah. It is hard. It is a hard subject. Memang kena banyak latihan dan banyakkan pemahaman. Sometimes people dia explain tapi dia tak cuba relate to the real world. So it's just a bunch of equations and a theory. So to me, I don't really like that lah. So I like to relate back to everyday life lah. Okay. Yeah. So saya daripada SPM saya terus pergi US. So ada culture shock, ada language barrier. Tak pandai physics. So that was what happened. Okay. Okay, next. So let's talk about this guy. Oh, it's almost time. Let's just talk about the concept lah, okay? So a boy of mass 35 kilograms stands on a weighing machine inside a lift. So when we have a weighing machine, what it is measuring actually is reaction force. It's not actually weighing mg tau. So kita ada weighing scale kan. So this is not me. This is, saya tengah refrain myself from saying Haikal. This is Soh lah. Okay, Soh. So Soh is on a weighing machine. And Soh punya weight is not actually based on mg, but it's actually R. The weighing machine is measuring R. So kalau Soh di tengah atas bulan, right? The reaction, the mg on moon will be lighter. Kan orang atas bulan kan dia macam terbang-terbang sikit kan sebab dia punya acceleration is smaller than on Earth. So let's say Soh went to the moon. He's an astronaut. That's so cool. So dia pergi moon and his acceleration or his gravitational acceleration on the moon is smaller. Therefore, Soh punya mg, right, the force that is going down, and Soh is standing still, so dia punya reaction force is equal to mg, but the mg on moon is smaller than the mg on Earth. Therefore, Soh akan jadi ringan. So weighing scale yang Soh bawa daripada Earth tu, dia letak dekat atas moon, dia duduk atas tu, dia cakap, oh aku dah turun berat macam tu. So ni atas moon lah. Lepas tu bila Soh turun ke Earth, duduk atas weighing scale, tiba-tiba naik a few kilogram. Sebab apa? Sebab the weighing scale measures reaction force. Reaction force. So berbalik kepada soalan kita ni. When we are in a lift and the lift is either accelerating upwards or accelerating downwards, kita akan, the net force in our y will be R minus mg, right? Will be R minus mg, and also akan ada this ma. We have acceleration, right? So our net in the Fy is not equal to 0, it is equal to ma. So this, we start with our condition first. Sorry, ma, this is Soh's mass. No, this is a boy. Soh punya berat bukan yang ni. So this is 35 kilogram times the acceleration, which is 2. So using this equation, you will get 35 times 2 positive, Lepas tu R minus mg. M is 35 and G is 9.81. So if you guys look at this equation, your R will be 35 times 9.81 plus 35 times 2. So it's 35, 9.81 plus 35 times 2. So dia jadi lagi berat. Sebab mula-mula kalau mg saja, this is mg. Tapi ditambah dengan this guy. So reaction force dia lagi besar daripada mg. The R is greater than mg. So weighing scale dia akan detect R sahaja. Dia tak detect mg, dia detect R. So akan tengok, oh sorry, it's not so. The boy will see the weighing scale, oh I'm heavier. It's because the weighing scale is measuring R. Okay, so that's it for today's class. Nanti kita sambung with this example in the next class. Okay, bye guys. Take care, stay safe. Jangan main-main dekat luar tak pakai mask. Bye bye.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome. Bye bye.
Doktor.
Thank you. Bye-bye.
Selamat tinggal.
Bye. Selamat tinggal. Over. Okay, bye.
Thank you,
Bye.
Doctor. Doctor, can I ask a question?
Yes.
For the survey, right?
Uh-huh.
Where do we get the answers? Because at the back of the book, they only give us the answers for the odd numbered questions. So where do we get the answers for even numbered questions? Do you happen to have it?
I do have the answers, tapi dia punya answer akan tunjuk after the assignment is due.
Oh,
So
okay.
kalau web assign chapter 2 ni due tomorrow, right? So should be dia akan reflect the answers after that.
No, not in the web assign, like for the book, for the
Oh, for
reference
the book. Oh, for the book saya tak ada juga. Saya hanya ada odd number saja.
Okay, thank you, Doctor.
Okay, welcome. Bye-bye. Sorry, tak ada that schema.